Yes, hello friends. So this is the video tutorial for today's GFG problem on today's swap diagonals. The question is very simple and it says, given you are given a square matrix, the task is to swap the element of the major and the minor diagonals. Major diagonals is the elements that lie from the top left corner to the bottom right. So basically from this 0 to 4, 8. This is the major diagonal, and minor diagonal is this one, which is that element that lies from the top right, which is this, to the bottom left, which is this. Nice. I am not autistic and I can identify left and right, but that's it besides the point. That is where this sum of the row and the column indices equals to n minus 1. So yeah, this is a property of minor diagonals that you can remember or you can even like see. So the idea of the minor diagonal is see this diagonal line. So the sum of the elements of the minor diagonal is r plus c equals to n minus 1. So this is a constant and we can even like see this. See this is 0 comma 2. So 0 plus 2 is 2. This is 1 comma 1, 1 comma 1, and this is 2 comma 0. Right? So that makes sense. But what we need to do here is that we need to swap the elements in the major diagonal and the minor diagonal. So this element will get swapped with this element. This element will not get swapped by itself, and this element will get swapped by this. So we'll go over the major diagonal. We'll find the opposite of it, or the like. See, what we actually need to do is just traverse the major. Okay, my bad. Traverse the major diagonal. Then for each element in the major diagonal, we just need to swap it with its opposite, or it's like a reverse value basically in this array. So we can see this is an array, so its opposite value would be this, which would be what? This is an n size array, right? N minus 1. So the opposite of it would be n minus 1 minus I. So we'll go over the diagonals, we'll find this j, and what we just need to do, like similarly we'll find it here also and here also. So it's fine for each I, we'll go over the diagonal elements. So diagonal elements will have the property of that their row is equals to I and their column is also equals to I. So we'll go over all the elements, which is at I comma I in this form, and swap it with this j. J is the opposite of it in the current row. So just need to swap this mat I comma I with mat I comma j. Yeah, this is it. It's a pretty simple question. The time complexity would be off in here. Space complexity would be 0 because of 1, because we are doing this swap in place or in the same matrix here. So we can see that we went over this array, then we find its opposite, which is this. We swap 0 and 2, so that is because 2 1 0. Then we go over here, we find its opposite, it's with the same cell, so that is we are swapping 4 with 4. Then we go over this cell, we find 8, its opposite is 6, so we swap 8 and 6. So yeah, this and this, these two get swapped, and yeah, that's pretty much it. Let me show you the code. It's pretty simple. So as we said, we'll find the matrix size. We'll go over all the diagonal elements. Diagonal elements have the property of that their row and column both are equals, and equal to I would be equal to I here. We'll find this j, which is the opposite of it in the current array or in the current row. So yeah, and we'll just swap these values. This works. Thank you for watching. If you were able to understand anything, give me a like and subscribe. All of those things. Bye bye. Thank you.